Hey, all you Gretas and Chutezcats out there. Today we're going to look at Chapter 2, Section 2. What is matter? So matter is anything that has mass and takes up space. So last time I checked, you guys all have a mass and you take up space. So look, you matter. It exists in three physical states. We have solid, liquid, and gas. This should be review from freshman year in biology and last year in your chemistry or ICP class. So this should be a very, very easy section for you. We have two chemical forms. So you can have elements, which are all the same atoms, or compounds, which are a combination of more than one type of atom. Elements and compounds. Elements cannot be broken down into simpler forms by chemical means. So they're represented by a one or two letter symbol. So C is carbon, AU is gold, hydrogen, helium, lithium, oxygen, all these things are elements. They're arranged in the periodic table based on chemical behavior. We currently have 118 of them, not all of which occur naturally. Then you have your compounds, which are two or more different elements held together in fixed proportions. H2O, NaCl, things that are kept together, which is water and salt. All right, then we have an atom, the basic building block of matter. An atom is the smallest building block of matter that an element can have that will still retain its chemical properties. So you can go down to an atom of carbon, an atom of oxygen, and it will still have the properties of carbon or oxygen. Each atom has three subatomic particles. You have your neutrons, which have no electric charge, and they're found inside the nucleus of the atom, which is different than the nucleus of a cell, those of you who are using Google and Wikipedia to teach yourself these things. Protons are positive and also found inside the nucleus. Electrons have a negative electric charge and they move very rapidly all around outside of the nucleus. So protons and neutrons in the middle, electrons bouncing around the outside. So each atom has that small central nucleus that has its protons and its neutrons. Okay, ready for some bad jokes? Neutron walks into a bar and he orders a drink and he tells the bartender, who's like, oh my goodness, Proton walks into a bar and he says, oh my goodness, I have had the worst day ever. And the bartender's like, oh my goodness, what happened? And the proton says, I lost an electron today. And the bartender's like, you lost an electron? Are you sure? And the proton said, yes, I'm positive. And there's a neutron joke too. Neutron walks into a bar and says, orders a drink. And he says, how much? And the bartender says, for you, no charge. Yay, okay, bad joke's out of the way. Maybe silly, but you might remember that and that could help you on a test. So, atomic number is the number of protons in an atom's nucleus. The mass number is the total number of neutrons and protons in an atom's nucleus. And then when you have isotopes of an element, they're going to have the same atomic number, but a different mass number. So they're going to have the same number of protons, which makes an atom, but a different number of neutrons. So whenever you have an element, it always is going to have that same number of protons every single time. Here is what an atom looks like. So you have your protons and neutrons in the middle and your electrons that are all bopping around on the outside. Molecule. Combination of two or more atoms of the same or different elements held together by forces known as chemical bonds. Your ion is an atom or group of atoms with a net positive or negative charge. And so they often have a little number next to it, and that's the number of positive or negative electric charges. And this is super important for measuring how acidic something is in water, which is its pH, which I will get to in a little bit. So if you want to think about Ion Television, the TV channel, it says positively entertaining. Well, that's great, but ions can also be negative. So it could also be negatively entertaining, which is way less of a fun TV channel. Acidity. This is the concentration or amount of hydrogen ions, H+, and hydroxide ions, OH-, that are found in a substance. They're measured with a scale known as pH. An acidic solution has a pH below 7, and a basic solution has a pH above 7, and a neutral solution, usually water, has a pH of 7. Here's your pH scale. So you go from super, super acidic, like battery acid. Then your 2 is like your stomach acid. Have you ever gotten sick and then your throat and your mouth like puked? And then your throat and your mouth just feel raw? It's because all of that acid that should have stayed in your stomach is now was in your throat and your mouth. So you're just digesting yourself just a little bit there. Things like lemon juice, vinegar, soda are all actually fairly acidic. Acid rain is a 4. That's really not good. Natural rain is slightly acidic, but not anywhere near a 4. Milk is barely acidic, but still a little bit acidic. Neutral is your water. Seawater is actually basic, and we'll talk more about that later this year. Baking soda. So you've all done the baking soda and vinegar lab. So when you take an acid and a base, what happens? You get some type of super cool reaction. If you haven't done that, you can try that. Please do it in your kitchen sink, not on a table. Then ammonia, bleach, sodium hydroxide. The stronger bases are going to be your cleaning objects. So in chemistry, organic compounds are carbon-based compounds that contain at least 2 carbon atoms combined with atoms of 1 or more other elements. So you need at least 2 carbons. Except CH4, that's the only one that's unique. So you have your hydrocarbons, compounds of carbon and hydrogen atoms. Then you've got your simple carbohydrates, and these are your carbon, hydrogen, and oxygen. And then you have your polymers, which are your complex carbs. Simple carbs are sweet. Complex carbs are more of your starches. And these are going to be simple organic, that take those simple organic compounds and bond them together. Polymers are essential for life. So major types, we have our proteins formed by nucleic acids, proteins formed by amino acids, nucleic acids formed by nucleotides, DNA and RNA, and then lipids, your fats and your waxes, which are made up of essential macromolecules. Technically not monomers, but close enough. So a monomer would be like your glucose, and then your cellulose would be your polymer. So think of a monomer like a bead, and your polymers are going to be like the necklace that the beads get put together to make. So you can go through physical and chemical changes. So this is seriously your chemistry class in a nutshell. So physical changes are things like changes in size or state, like going from ice to water. They do not involve changes in the chemical composition. It's still water, it's just frozen, or it's now gas, still water. Then you have chemical changes or reactions that involve changes in the chemical composition of the substances involved. And once again, I think cooking is a good example of this. If I handed you a freshly baked cookie and I asked for the flour back, you couldn't give it to me because it's been chemically changed and you can't separate those things anymore. So chemists use a chemical equation to show how the chemicals involved are arranged in a chemical reaction. So here we go. Reactants react. Nice and easy to remember. So that's what goes into a chemical reaction. So here we have carbon and we have O2. So we have a carbon atom and we have an oxygen molecule, and it's a molecule because there's more than one. Then our products are produced. This is what comes out. So this is our ingredients and this is our finished cookie. So it makes carbon dioxide or CO2 and energy. Hooray! Law of conservation of matter. Hey, here's a law. So law of conservation of matter says physical or chemical changes can take place in chemical reactions, but no atoms are ever created or destroyed in the process. So when you lose weight, how you actually do that is the carbon in you becomes more of the CO2, and that leaves you when you breathe out. And that is literally how you lose weight. They did studies on it. You actually lose most of it as you sleep. So when you go through the process of losing weight, it's not like you pee out more or you poop out more. It's the way that physically leaves you is from you breathing out. So if you're doing exercise and you're breathing really heavy, that's awesome because that's molecules leaving your body. But no atoms are ever created or destroyed. They're just moving around from place to place. And you have survived round 2 of the notes. So before I go, I want to remind each and every one of you that you matter, you are smart enough, you are good enough, and people like you. And in case I don't see you, good afternoon, good night, and good God, do your homework.